Hey everybody, welcome back to the channel. So in this next video, I'm going to go over the assembly of the scissor mechanism, the legs, and I'm going to show how I clamped it down to the table, got everything aligned, tacked so everything can kind of stay in position and not get deformed too much from all the heat from the welding. And we're going to show how that goes together. So let's get into it. Okay, so this is 1-inch square tubing. This is going to be the spacer that holds the 1/4-inch by 2-inch plate on either side of the scissor leg apart. I'm going to need 2 of these for each side, and I'm also going to cut some 1/4-inch round stock the same length as these pieces. Those are going to act as spacers in the scissor leg to help hold everything flat. These pieces of tubing I'm cutting on the cold cut chop saw because it gives me the squarest cut, so I have very little cleanup to do afterwards. You could cut them on a bandsaw. You could cut them in various ways, but I picked this way. I did just get a plasma cutter, which I might use for some of the other parts of the project, but I didn't have it when I was making these. Now I'm checking my table. I've clamped some fences on here, and I'm checking them in all 3 directions to make sure that they're square. That's going to help keep everything aligned well, because this is one of the critical parts of the mechanism. You can see the flats that I have, I've ground the mill scale off where these spacers are going to go. And you can see that's the 1/4-inch rod that's going to go between them. And the reason I'm placing those spacers at a 45-degree angle like I just had them is partially so that I can access the welds better when I go to weld it together, and also to help the stresses on the flat steel. And we'll kind of go over that. That's a 45-degree angle on this magnet. And I'm going to use the magnet to hold this guy in position. I have my locations marked out on the flats. And now I can center it up and down on the 2-inch measurement on that flat. And I can place one of these at each end. Now I located them so that they are out of the way of any of the operations of the scissor mechanism. And I made sure that they were clear of the caster, because one end of this pair of flats will be holding the metal roller that's going to help raise and lower this unit. So I want to get these in there pretty accurately, but it's not crucial how these things are positioned, but it does help them when they're neater, and it helps the appearance. And now I'm going to use another pair of magnets to set the 1/4-inch rod in place. Again, these are not taking a lot of the stress. They are simply to hold the space between the 2 flats. Right where that orange spring clamp is, there will be a bolt going through a piece of square tubing that makes up the other leg. And there'll be a washer on either side of that tubing. So that's what determines the space between these 2 flats. I want that washer in there to help with the binding so that the 2 parts move freely. Now you can see how they sit, and I'm going to put a chunk of my square tubing with a 1/4-inch flat in between to hold them at the right spacing. However, my magnets are in the way. So I could cut the tubing down, but it's just as easy to spin the magnet around and just put it on the outside of the metal rod for each one, and then that'll create some space for me to drop this spacer in. The spacer didn't need to be that long. I just had that chunk of scrap. And it was a little easier to move the magnets than it is to set up the saw just to cut that part down. But the key is to have something fixed between the two so that when I weld things, it doesn't curl the metal up any more than it has to. It's going to want to move, and it's going to move to a degree, but the more I put good solid spacing in there that I can clamp against, the more flat and true this thing will stay. Now, the quick grip, I wouldn't use this for most welding applications. You'll melt it immediately, but it's okay to hold it in place for the time being while I get the rest of this set and get some better clamps on there. Now, I will have all thread going through this leg that will line up with the other leg, so I want everything to be nice and square off of the holes that hold the all thread. And by putting that long piece of all thread in, I can check it for parallel with the fence at the end of the table. And if it's parallel, that means that the leg and the holes in the leg are square to each other. And here I'm double checking my layout for the holes just to confirm that everything's as square as I can get it. Mainly that's going to help the operation. Things won't bind. It'll be easier to fit the bolts in there. And now I can check that space from the fence to the all thread, and I like it there. So that means I can take some stronger clamps that I can leave on there while I'm welding, and I can clamp this flat to the table. That will help keep everything true and keep everything parallel. Here I'm adding another piece of scrap to space out the two ends, because when I weld my 1 inch by 1 inch tube in there, the two tips of these flats are going to want to pinch together. That's just going to happen from the stress of the weld. So by putting this in there, I can reduce that a little bit. And that's where moving things around as you weld and moving the heat from place to place will help as well. Some C-clamps to help keep things firmly in position. And if you're wondering, the reason I didn't just use the end of the steel to square things up, that's not the critical point. It's cut as a round simply to make some clearance for movement, but that steel end is not as accurate as the holes are. So that's why I'm going with the holes, because it's a more critical dimension. I've got my other spacer in here because I'll have the same problem at this end. When I weld that spacer in, it's going to pinch those tips together. Now I can make sure everything's seated on the table. And at this point, I'm only tacking it. The temptation is to just weld things out and get going. But if you do that, everything will move more than necessary. I am tacking the opposite corners on these spacers. And because it's turned at a 45-degree angle to the leg, the opposite corners that I'm tacking are the ones that are in the center of the leg. By doing this, you keep the stresses more even, and it will reduce their tendency to roll and get out of parallel with each other. The other thing is, it's a good idea once you get a tack on there and that metal's not going to move, get your magnets out of the way, because if you overheat the magnets, you can damage them, you can affect their magnetism, and they weaker. And so it's a good idea to only use those for getting things tacked in place and then get them out of there. And even with the tacks, I try to move around as much as possible, and I try to do opposing sides at the same time. So I'll do one side, then I'll jump to the other and do the opposite. That will keep the stresses countering each other. If you try to work your way around around the outside, you can kind of twist things as you go. So I'm going to work back and forth. try to get everything tacked so that it won't move when I pull it out of the clamps. And now I've got it rolled down onto its side. And you can see I've got 3 good clamps on there holding it flat to the table. That's going to help keep this thing from turning into a big S when I weld it out. Because that is a longer bead to run. That's about 1 inch to 1 1.8 inches long. So you spend more time on it. So now if I jump to the opposite face, I'm adding the strain in the opposite direction. And also that weld is not parallel to the leg and it's not perpendicular to the leg, because both of those will have different effects on how things warp and deform. So I'm kind of experimenting with this. I don't know that this will help, but from what I've seen before, I'm hoping that it will. And the more I move around, I'll weld 2 opposite faces and then go to the other end, and then weld 2 opposite faces and then jump back. And then I weld my spacer in between. And the other thing is, once I get this lower face all welded out, the opposite face, the one on the top right now, is not welded. And it would be nice to weld them both at the same time, but in this circumstance, it was easier for me to weld out the lower one while it's all clamped down. And then I let it cool, and then I'll pull it out of the clamps, flip the whole thing over, set it back up, and weld it out again on the opposite face. But if I do it that way, that's the best way that I know how to control the movement from the heat. And then I'm going to repeat that process for the next leg. And that will get me a pair of these put together. Once I have them both welded out, I can assemble the scissor mechanism. I can put the casters in place, and I can mount them to the base of the unit. That's going to allow me to start laying out the dimensions for the support for the jack, and I'll be cutting out some components for that jack mount, and hopefully I'll be getting to use my new plasma cutter to make some of these cuts, and I can show you how that works and give you a little feedback on what I think of the plasma cutter. All right, so that's how we got the legs put together. That gets us one step closer to putting this whole thing together. I believe the next video is going to be working on the base and more of the mechanism for the jack assembly and how we're putting the jack together. So stay tuned for that. Hope you can join us, and don't forget to like and subscribe. Thanks for watching.